For the 2017 free response exam, question number 2, it deals with a situation where you're at a grocery store, um, or it's a grocery store, and they give you the rate at which bananas are being removed from a display stand, and also where the rate at which bananas are being added to the display stand. So this is the rate at which they're being removed, okay, and it's in pounds per hour, okay. So FFT is pounds per hour, and GFT is it's removing. So this isn't another in and out problem, okay. And hopefully you're getting confident. You're going, I know what this means, and I can explain this, and I can answer questions on these in and out problems, okay. All right, so today's going to be the last day on these in and out, or they're also called rate and accumulation problems, okay. So here's the first question, okay? So how many pounds of bananas are removed from the display stand or table during the first 2 hours the store is open, okay? So if we have a rate, the rate at which they're being removed, which is f of t, if we simply integrate that for the first 2 hours, right, from 0 to 2, then that's going to give us the pounds of bananas that were removed from the display stand. So let's go to our paper. We're going to write that up, and then we're going to use our graphing calculator to put that in and get the approximate value. Okay, so we're going to want to integrate for part A. We're going to want to integrate from 0 to 2 because that's the first 2 hours, and we want to integrate the rate at which the bananas are being removed from the display stand. So that would be f of t, because that's the rate at which they're being removed, okay? And then dt. Okay, so think about this. This f of t is pounds per hour, and then we're multiplying by hours, so that's going to give us the pounds of bananas that were removed, okay? All right, so we're going to go to our graphing calculator, and we're going to put this in and see what we get, okay? All right, so on our graphing calculator, we want to make sure that we're in radians because we're dealing with some trig functions here. So we want to verify, okay, look up here where I'm highlighting, okay? We want to make sure that that's in radians, all right? So go over here to y equals, okay, I'm going to clear out the functions that I have. That's from the other day, okay? And we want to type in f of t, which was 10 plus, and then we could use a parentheses, and 0.8 t, but in this case we have to use x because of our graphing calculator, and close the parenthesis, and then sine, and then alpha x, or yeah, alpha x to get the fraction bar, and then x cubed over 100. Okay, so now we're going to go back to our home screen, so we won't have to type that in. And let's just double check. 10 plus 0.5x sine of x cubed over 100. So it's just good to make sure that you type this in correctly, okay? Because it'd be awful if you knew what to do and then you type this accidentally incorrectly, okay? So back to our home screen, and then we're going to integrate. So that's alpha window, and we're going to integrate. So function integrate is number 4. And we're going to integrate for the first 2 hours, so that'd be 0 to 2. And now instead of having to type the function in, we can type alpha trace and select number 1 for y1, and then dx, and press enter, and we get 20.051. So let's go back to our paper and let's record that value. So from our graphing calculator, we're going to put an approximate, and this is 20.051. Okay, so the question was, how many pounds of bananas are removed from the display stand during the first 2 hours? Okay, so during the first 2 hours the store is open. Let's write this as a sentence. During the first 2 hours the store is open. 20.051 pounds of bananas are removed. from the display stand. Okay, and that's the answer to the first question. So let's go to question B, or part B. So for part B, it says find f prime of 7, and then using correct units, explain the meaning of f prime 7 in the context of the problem. Okay, so we got to find the derivative of f at 7. Now, this is a rate, right? So we're looking at a rate of a rate, okay? So we'll talk about the explanation of that in just a minute, okay? But we got to use our calculator to find the derivative, okay? All right, so let's go back to our calculator and put that in. So we want to find the derivative at 7 for this function f, which is we stored in y1, okay? So we'll press alpha window, okay, and we want to do 3 for numeric derivative. And we want to take the derivative with respect to x of y1, so alpha trace number 1. And we want to find this at 7, okay, after our 7, okay? Or at t equals 7, okay? All right, and then we'll press enter to get the value. And we get negative 8.1195. So you could either answer this as negative 8.119 or negative 8.120, okay? Because the 5 will make this 9 become 10, which makes the 1 become 2, okay, if we carry the 1. All right? Okay, so let's go back and record this on our paper. All right, for part B, we have f prime at 7, okay, and that's approximately negative 8.120. Again, you could say negative 8.119, okay? Now that's the derivative, right? But what is f describing, okay? So f is the rate at which bananas at the display stand or table are being removed, right? It's a rate. So this negative tells me that that rate is actually decreasing, okay, at this time, okay? So at t equals 7, we could say that at t equals 7 hours, or 7 hours after the store has opened, the rate and we're going to describe the rate. Okay, so this rate at which bananas are being removed from the display table, the rate at which bananas, and I spelled bananas wrong earlier, bananas, the rate at which bananas are being removed is, okay, so it's the rate that's decreasing, okay? So this rate, the rate at which bananas are being removed is decreasing, okay? And this is really, this is like a second derivative because f is a derivative. So f prime is like the second derivative, okay? So the rate at which bananas are being removed is decreasing 8.120 pounds per hour per hour. Okay, so at t equals 7 hours, the rate at which bananas are being removed is decreasing 8.120 pounds per hour per hour. Now, all of this could be written like this: pounds per hour squared, okay? All right. And then up here, I noticed this, I said it, banana should be only one in right there, okay? All right, so let's go to part C. All right, for part C, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? And then we need to give a reason for our answer, okay? So now we're not talking about the number of bananas that have been removed. or the bananas that have been added, right? Because we have a function that adds it, right? We want to know the number of pounds of bananas on the display table. Is it increasing or decreasing? Okay, so to figure that out, we got to look at a rate, okay? And we got to take a look at the rate at which it's being removed and added at that time. If the rate is larger than the rate at which it's being removed, then the number of pounds of bananas on the display table has to be increasing. If we're removing at a faster rate, then the number of pounds of bananas on the display table has to be decreasing. Okay, so we can look at the number of pounds of bananas on the display table is changing by two rates being put together. Okay, so it comes up with the rate at which it's being removed. That would be the minus part. Okay, because that's the out. We started with the out part up here. Okay, and then this is the in part. Okay, when we talk about in and out problems. Okay, so let's look at what is g of 5 minus g or f of 5. Okay, because g of 5, they've been adding bananas now, right? Okay, and f of 5, they're removing. Okay, so at t equals 5, we've got to put these two together. Okay, if it comes out to be positive, it's increasing. If it comes out to be negative, it's decreasing. Okay, so we're putting two rates together to make a new rate. All right, okay, so let's go to our paper. Okay, so for part C, we want to take a look at what is g of 5 minus f of 5. Okay, because this is the rate, these two together is the rate at which the number of or the pounds of bananas is changing. Okay, so let's go to our calculator and let's put this into our calculator and take a look and see, does that give us a positive value or a negative value? Okay, so what we're going to have to do for this one in our graphing calculator, we're going to have to put in g of t for our y2. Okay, so g of t was 3 plus 2.4 natural log of t squared plus 2t. Didn't mean to put that second parentheses there. T squared, so we're going to have to use x squared plus 2x. I'm going to close my parenthesis. Okay, now remember, this function is only good from 3 to 12, okay? All right. Okay, so now we're going to go, now y2 is our g, right? Okay, so I'm going to go back to my home screen. So I'm going to quit. And we want to find alpha trace, and we want to do 2. So we want y2 first because that's the rate at which it's adding bananas. Okay, so we want that one to be positive. Okay, so y2 of 5, and then minus, and then y1 was the removal rate, right? So we're going to go trace, and then number 1, y1, and of 5. Okay, so the overall rate would be negative 2.263. So let's go back and record that on our paper. Okay. So this comes out to be, from our graphing calculator, negative 2.263. And this is also pounds, this is pounds of bananas per hour, okay? Now, this negative is decreasing, right? So this is the overall rate at which the pounds of bananas on the display table is changing, okay? So because this is negative, okay, we're removing faster than we're adding, okay? All right, so let's do the explanation of what this is, okay? So we know that g of 5 minus f of 5 is less than 0 because this value came out to be negative, okay? So we'd say the number of pounds of bananas on the display table is decreasing at t equals 5 because, okay, here's the reason why, the explanation, okay, because g of 5 minus f of 5 is less than 0. Now, an alternative way of saying this is that g of 5 is less than f of 5, because you could move this over, okay? So I'm going to say this because this isn't the only way you could make their justification of why it's decreasing, okay? Or g of 5 is less than f of 5. You could say it that way too, okay? So g of 5, remember, that's the function that's adding bananas back, right? And f of 5 is the removing, right? So the rate at which it's removing is larger than the rate it's adding. Therefore, it would have to overall be decreasing, okay? Let me slide that up, okay? Because I realized you guys couldn't see that, okay? So, or g of 5 is less than f of 5, okay? You could say it either way, all right? Okay, hopefully you're starting to, like, I'm starting to get these better. You're doing a better job at these, okay? It's just, it's practice. And the more of these you see, the more you realize, oh, that's just an in and out problem, okay? Oh, that's just a rate and accumulation problem. And you're starting to recognize these because this will be asked on your AP exam, okay? All right, so let's go to question D. Okay, so for question D, okay, they're asking how many pounds of bananas are on the display table at time t equals 8. Okay, so we have to do a couple things. We have to, how many pounds of bananas did we start with? Okay, then how many pounds of bananas have been removed? And then how many pounds of bananas have been added? Now, removal started when the store opened, right? But the adding didn't start to happen until 3 hours later, right? 3 hours after the store had opened, okay? So that means that this didn't start working until 3, okay? And so we want to integrate. We're going to start with 50 bananas, and then we're going to remove the total of bananas that have been removed from 0 to 8, but then we need to add back in how many bananas have been added to this, right? And that would be the integral of g of t from 3 to 8, okay? All right, so let's go ahead and do that. So for part D, okay, we started with 50 bananas, and then how many pounds of bananas did I said 50 bananas, but that's actually 50 pounds of bananas, okay? Then how many pounds did we remove? So minus, we're going to take the integral from 0 to 8 of f of t dt, okay? What we started with, the amount that we removed, and now how much do we add back? So now we're going to have to add the integral from 3 to 8 of g of t dt, okay? And we want to know, what does this come out to be, okay? So we started with 50, we removed a certain amount of pounds of bananas, and then we added a certain amount of pounds of bananas, okay? And let's go to our graphing calculator and let's put this in and see what we get for this one. So in our calculator, we enter 50 and then minus in the alpha window for function integrate number 4, and then from 0 to 8, because once again, that's the rate at which we're integrating, the rate at which the bananas are being removed per hour, right? Pounds per hour. And then that was alpha trace and then number 1, okay? And then dx. And then we want to add to that the integral from 3. Now, again, why 3? Because they didn't start adding bananas back on to the display table until 3 hours after the store had opened. So from 3 to 8. And then the adding function, which is g of t, which was our y sub 2. And then press enter, and 23.347 pounds of bananas, okay? So we'll go back and we'll record that on our paper. So this is 23.347. and that's pounds of banana, okay? All right, so let's write a statement for that. So at time t equals 8, there is 23.347 pounds of bananas on the display table. Okay, and that's how you did a rate and accumulation. This is the last one we're going to do. We're going to move Wednesday into some other different areas, some different free response type questions, and hopefully you're gaining a little bit of confidence and getting a little bit better each time on these. Okay, so I'm probably going to give you one of these later on just to keep you fresh, maybe like next week or something. Okay, all right, So let's move on to the next problem, which is question number 4. So for the 2017 free response question number 4, this scenario deals with a potato that's being taken out of for the 2017 AP Calculus AB free response number 4, this deals with a situation where you're taking a boiled potato from a pot that's in the kitchen and it's cooling, right? And they're giving you the initial temperature is 91 degrees Celsius. Now they actually tell you this a couple places. Okay, so here, the internal temperature of the potato is 91 degrees at time t equals 0, but they also say it right here. So there's 2 places they tell you that. The internal temperature of the potatoes is greater than 27 degrees Celsius for time t greater than 0. And they never give you extra information. We're going to use that information somewhere in this, okay? And then the internal temperature of the potato at time t minutes can be modeled by a function h that satisfies this differential equation. So h is the temperature in degrees Celsius and t is the time, right? And so this is the rate at which the potato is, in this case, it'd have to be cooling, right? Because it's taken out of the pot, okay? All right, so let's just jump in and answer question A. So question A is write an equation for the line tangent to the graph of h at t equals 0, and then use the equation to approximate the internal temperature of the potato at time t equals 3. So let's do the first one first. Let's write an equation for the line tangent to the graph of h at t equals 0. Okay, so I'm going to go to my paper and we'll work that one out. Okay, so to write the equation of the line tangent at t equals 0, we need the point at t equals 0, and we do have that, right? That's h of 0 is equal to 91. And then we also need to know the slope at 0, okay? So that'd be dh over dt at, okay? And it would be h is equal to 91. Now, why am I saying h is equal to 91 instead of t equals 0? Because our differential equation says it's -1/4 times h minus 27. So the rate at which it's decreasing, the temperature is decreasing, depends on the initial temperature or the temperature that we're trying to find it at, okay? So this would be -1/4 times and 91 minus 27. Okay, so you're not going to be able to use a calculator on this part. And now I know on the AP exam, you're going to be able to use a calculator wherever you want, okay? But in this instance, they didn't want you to be able to use a calculator, okay? So that would be 64. So they actually give you nice numbers though, because this is -1/4 times 64, okay? And then that would be -16, okay? All right, so we can write our equation. It would be y is equal to my slope, which is -16 times t minus 0, or just t, and then plus 91. Okay, so this would be y is equal to -16 t plus 91. Okay, so that's the equation of the tangent line, all right? Now, the only reason I went from here to here is because we were minusing 0, and so you can just write it as t minus 0 is just t, okay? So let's go to the second part of this question, and they ask you, okay, use the equation to approximate the internal temperature of the potato at time t equals 3. So that would be, we're going to approximate h of 3, okay? So that would be h of 3 is approximately negative 16 times 3 plus 91, okay? So that'd be negative 48 plus 91, okay? And then negative 48 plus 91 is 43. Okay. At t equals 3, the internal temperature, I think internal, yeah, the internal temperature of the potato is 43 degrees Celsius. Okay? And that's the answer to question A. All right, so for part B, it says use the second derivative of h with respect to time for the second time to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. Okay, so we use this tangent line, right? But if the curve, if the actual function was concave up, then think about that bending up, okay, then that would mean our tangent line approximation is an underestimate, okay? But if our function was concave down, right, then it would be curving down, right? And then that would mean that our tangent line is an overestimate. So we got to determine the concavity of this, right? Okay, so first of all, let's just figure out, okay, what's the second derivative, okay? Let's do that first. And I'm going to go to my paper and we'll do that. So for part B, we know that the derivative dh over dt is equal to negative 1/4 times h minus 27. All right, so we need to take the derivative of this, right? Okay, so this would be negative 1/4 times the derivative of h minus 27 with respect to time, right? So that would be just dh dt, right? Because this is just 20, the derivative of 27 is just going to be 0. So negative 1/4 times dh over dt. You know what? Hold your horses. I just made a mistake and my notation's bad, okay? So let me erase this, okay? I just made a boo-boo, all right? Because what are we doing? I'm saying this is equal to the first derivative, right? We're taking the second derivative, okay? So the second derivative of h with respect to time for the second time is equal to negative 1/4 times, and the derivative of h with respect to time would be dh over dt minus, and then the derivative of 27 would be 0, okay? So now dh over dt is this negative 1/4 times h minus 27. So this is negative 1/4 times negative 1/4 times h minus 27, okay? So what's negative 1/4 times negative 1/4? That'd be positive 1/16, right? So that'd be 1/16 times h minus 27. Okay, so that's our second derivative, okay? So let's go back and let's read the question again. Okay. So we want to use the second derivative to determine whether part A is an underestimate or an overestimate of the internal temperature. So we got to determine the concavity of this, right? Now, a few things to think about, okay? If you look at this, I'm going to go back and forth between this and my derivative, okay, or my second derivative. Okay, so we can determine the concavity, but the concavity is determined on h, right? All right. Now, it depends on what h is, right? If h is bigger than this 27, this is always going to be positive, and then this is going to be positive because 1/16 is positive, right? But if h is under 27, okay, then we know that it's going to be negative, right? So what was it at 3, right? Okay, so let's go back, and what did they tell us at the very beginning? And this is where you need this piece, okay? The internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. So for greater than 0, for all the times, H is above 27 degrees Celsius, okay? So back here we could say H is greater than 27 degrees Celsius for T greater than 0, okay? What does that mean? That means this is always going to be positive, right? So on this interval, H of T is concave up because the second derivative is positive, okay? So H of T, and it's going to be concave up for all T values, okay? So H of T is concave up for all T greater than 0 because the second derivative of H with respect to time for the second time is greater than 0 for T greater than 0. So it's concave up. So we have a function that's concave up and we have a tangent line, right? So this is the actual function. This is our estimate, right? We're off because we found this at 0, right? So right here would be like if this is t equals 0, t equals 3 would be somewhere like right in here, right? And there's a gap between the two. But since we know it's between what the actual value is, which would be right here, and the estimate that we did with the tangent line, right? So because it's concave up, I know the actual is more, right? So that would mean our estimate in part A is an underestimate, okay? So therefore, and this, we've seen this a few times now, right? So therefore, the estimate in part A is an underestimate. Okay? And that's all we have to do is for part B. All right? All right, so let me go back to our question and we'll look at part C. Okay, so for part C, for t less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g, satisfying this differential equation, right? And then where g of t is measured in degrees Celsius and g of 0 is equal to 91, find an expression for g of t based on this model was the internal temperature of the potato at time t equals 3, okay? So this is a differential equation, right? And we need to figure out what g of t is. So this is a separation, this is gonna be a separation of variables, okay? All right, so let's go ahead and do that. I'm gonna grab my paper and we'll work that one. Okay, so what we know for part C is that dg over dt is equal to this. And we also know g of 0 is equal to 91, all right? So what we wanna get is our g, which is g minus 27 to the 2/3. I need to get that over to the left-hand side. And so this is going to become -1 and then dt, okay? So this is going to be 1 over g minus 27 to the 2/3 power is equal to -1 dt. And I forgot dg right here, okay? So then we're going to integrate both sides, okay? And then this one I'm going to rewrite as g minus 27 to the -2/3. And then dg is equal to the integral of -1 dt. Okay, now if I let u, I'm going to do u, I'm going to let u equal g minus 27, then du would simply be dg, right? dg, okay? And so then this is u to the -2/3. You wouldn't have to do a u substitution on this, okay? You could just do it mentally, all right? So this is u to the -2/3, and then du is equal to the integral from -1, or not from, the integral of -1 dt. So we're going to add 1 to this and divide by that new power, right? So we're going to add 3/3 to this. That would make u to the 1/3 divided by 1/3, but a better way is to multiply by 3, okay? And then that's equal to -1t, or negative t, plus c, okay? Now this u gets switched back, right, to g minus 27. So this is 3 times g minus 27 to the 1/3 power is equal to negative t plus c, okay? Now, for this problem, what I would do, I think I would find the c right now, okay? So you have two options. Get g by itself and then plug the 0.91 in, or the other option is to go ahead and plug it in right now and figure out what c is. That's what I'm going to do. I just think it's going to be a little bit easier, okay? So this is going to be 91 minus, right, 3 times 91 minus 27 raised to the 1/3 is equal to, because this is going to be 0, right? So that's just c, okay? So 91 minus 27, that would be 64. So this would be 3 times 64 to the 1/3 power is equal to c, okay? And then, okay, so what could you cube to get 64? Well, it'd be 4, right? So this is just 3 times 4, which is equal to c, which means 12 is equal to c, okay? So now back here, this is our actual equation, but now we know the c value right here, right? That is 12. So really what we have is 3 times g minus 27 raised to the 1/3 is equal to negative t plus 12, okay? Now, we want to get g by itself, okay? So the very first thing we'd want to do is to get rid of this 3, okay? So this is going to be g, and 1/3 power means cube root, right? So then g minus 27 raised to the 1/3 power is equal to, you could write this as negative t plus 12, or 12 minus t over 3. I'm going to write it as 12 minus t over 3, okay? And then we're going to want to cube both sides because I want to get rid of the 1/3 power. So I'm going to raise both sides to the 3rd power. So that would give me g minus 27 is equal to, okay, and this right-hand side would be 12 minus t over 3 to the 3rd power, and then adding 27. So g is equal to 12 minus t over 3 cubed plus 27, okay? And there's only one function for this. That's it, okay? All right? So, okay, so g of t would be the function 12 minus t over 3 cubed plus 27. Now, there's other ways you could solve this, okay? There's other ways you could get g by itself. And so I want to make that really clear. This is not the only, this is one version of the answer, okay? So if you cube the top and you cube the bottom and got a common denominator and did stuff like that, that'd be fine. But you don't have to, okay? If you get an answer that's a correct answer, that's all that matters, okay? And you show your work that leads to that answer, okay? All right, so then we need to also, because there was another part to this, right? So I'm going to grab my problem back, okay? Find an expression for g of t. We did that, right? Okay, and based on this model, what is the internal temperature of the potato at time t equals 3? Okay, so what was the temperature of this potato? Okay, so we got to find that. So what is g of 3 for our function? What's g of 3? And g of 3 would be 12 minus 3 over 3 cubed plus 27. Well, 12 minus 3 is 9, and then 9 divided by 3 is 3, and then 3 cubed is 27. So g of 3 is equal to 27 plus 27, right? So 27 plus, well, 20 and 20 makes 40, right? And 7 and 7 make 14, so this is 54. So g of 3 is equal to 54. Now, that's 54 degrees Celsius, right? Okay, so this estimate is saying that the temperature would have been 54 degrees Celsius, okay? And you can't see that. Sorry, guys. Let me take this off. I'm busy talking and I don't look at the screen to see where it's at. Sorry. Gosh darn. Mad at myself right now. Okay. So what I was saying is G of 3 is 12 minus 3, which is 9, divided by 3, which is 3. Cubed is 27. So I have 27 plus 27, and then that would be 54. Okay. So this is 54 degrees Celsius. Okay. That's what this one predicts. Okay. So I would write a little statement here. The internal temperature of the potato is 54 degrees Celsius at T equals 3 minutes. Because remember, T was measured in minutes. Okay. All right, guys. All right. Hopefully, you're like this is starting to catch on, and you are really you're starting to get better because do you notice that these problems look very similar to other problems that we've done the last the free responses we've done over the last couple days that we've done the free responses. Okay. So hang in there, guys. Hey, if there's anything that you need, just let me know. If you're having struggles with something, if you're having problems, if you're having technology problems, or anything, reach out to me, get a hold of me. Okay. If you, I will do a one-on-one tutoring session with you. If it's 9 o'clock at night and that's the only time you can do it, I'll do it at 9 o'clock. Okay. Probably won't do it 2 in the morning. All right. Cause I know a lot of you guys are up at 2 in the morning, but I like to sleep. Okay. But I'm happy to help you guys. You just got to let me know, like, Mr. Mitchell, I need help. I don't understand what's going on here. I can pull up my document camera and we can do a live session where I'm discussing things, okay, with you. And I have no problem doing that, okay? Because this is about you right now and getting you ready for the AP exam, okay? So you guys can do this, all right? If you take the time and put the effort in, you're gonna do okay on this exam, guys, okay? You're gonna do just fine, all right? So hang in there, and I'll see you tomorrow, okay? Take care, guys. Have a great day. Bye.